So we're going to be talking about leveraging elastic web scale computing with AWS today. And Fiona has already introduced me, so I won't go through it again. So what I'm trying to cater here to is if you are somebody who has spun up one or two or many instances on AWS or are running applications on AWS already, maybe you're facing some performance issues, or maybe you're running up your cost because you're over-provisioned. So leveraging elastic web scale computing with AWS is for you. And also throughout the talk, I'm going to try and highlight some tips for the developers out there as well. If you're designing applications, how would you like to design your application so that they can scale? So I'm going to try and do that as well. So as Fiona already did a bit of housekeeping, we'll run approximately about 55 minutes, and at any point in time, feel free to ask questions on the questions panel. I think we've got a couple of people answering questions today. If I finish early, I'll stay back and answer some questions as well. All right. So these are the topics that we're going to cover. So I intend to cover some basics first. You might already know this, so I'm going to fast track some of the basics. So these basics are the building blocks for the main topic, which is leveraging elastic web scale. So you won't hear me talking about scaling until the very last bullet point, but I'm going to be running through the first 6 stages quite quickly. So most of the time we will be talking about scaling. So to start off with, I'll quickly cover some EC2 basics, the life cycle of an EC2 instance, various instance types at your disposal, and Amazon machine images, or AMIs, or AMIs as they are called as well. I'll spend some time on bootstrapping EC2 instances and various techniques to bootstrap, because this will be crucial in deciding our scaling strategies. A very brief slide or two on CloudWatch, and then we'll get on to the main topic, which is autoscaling. We'll look at why autoscaling, what is autoscaling, and how do you do autoscaling. We'll go through a quick demo and then end with a few pro tips and some advanced features on autoscaling which are available now. So let us start off with EC2 basics. So if you already did know, EC2 is elastic compute service. So notice the word elastic in the name of the service. It is, in its most basic definition, a virtual server on the cloud. So you can spin up one instance, or you can spin up thousands of instances using either the management console or a CLI or an API at any time you choose. So there's no provisioning lead time. You don't have to wait for a week or a couple of weeks to get a server running. You can spin up instances of various size and types. So you've given a whole platter of choices. We'll see some of the choices in one of the later slides. And you can provision your instance in any AWS region. So we are in about 11 regions and 22 availability zones. So you can spin up a server right now in Sydney, and you can spin up a server right now in Frankfurt if you wish to. And as we already said, EC2 instance is a virtual instance, and you might already know it runs on an underlying hypervisor. Having said that, what I'm trying to say is, once you spin up an EC2 instance, you have complete control of your EC2 instance. You can start it, stop it, configure it, install whatever you want on it. You can monitor your server or terminate your server when you're finished. You pay only for the capacity you use, which means that as soon as you start up an instance, your billing starts. And once you stop your instance, you stop paying for the compute. And when you terminate the instance, your billing is rounded to the next hour and you stop paying. There are also a variety of pricing models which are available when you consume an EC2 service. We'll see a little bit of the pricing models as well. Excuse me. So these are the various pricing models available to you. And we're talking about elastic compute and how to leverage it on AWS, and why are we talking about cost models? Isn't elasticity and scaling out all about performance? Not really. So scaling is quite a key in optimizing your spend for your application. I'll show you a few graphs on basic IT cloud strategy and utilization graphs, which will help you understand better in one of the later slides. So just to run through some of these cost models, your on-demand is probably the most common pricing model customers start with. So you really don't know what your capacity requirement is. You might need an instance today. Tomorrow you might need 5 instances. Maybe you have a marketing campaign coming up in a week, and for the duration of the marketing campaign, you might need hundreds of instances running. And when the campaign is over, you just need a couple of instances. So you really don't know, your capacity or requirement is vary. Spin up on-demand instances, and you are paying for it by the hour. So you spin up your instances just when you need them, pay for them as long as you use them, just like you pay for electricity or water. So you're basically purchasing compute power like a utility. That is basically the on-demand pricing. So now reserved. If you're running a production application, or say a database which needs to be on 24 hours a day and 365 days a year, you can reserve this compute capacity and pay a reduced price. There are a few models of paying for reserved compute capacity. So you can either pay all upfront, or a partial upfront, or no upfront. All you need to do is you need to say that, yep, I need to reserve this for a year or 3 years, and then you get a reduced price for helping AWS capacity plan. We even have our trusted advisor service, which will look at your usage and tell you how you can reduce price. It will tell you about maybe you've been running this instance forever. Maybe you should consider using reserved instances. So it will give you handy tips as well. Now, spot instances. Spot instances are an interesting case. It's basically you're bidding for unused EC2 capacity. So we have hundreds of thousands of 10,000s of servers in Amazon data centers. A lot of them are used on demand and reserved. We always have spare capacity. So those you can bid on using that spare capacity. You can say that I'm willing to pay 3 cents hour to spin up an instance. So if your bid matches the going price, you will get that instance. Typical use cases are for time-insensitive workloads like batch processes and stuff like that. And there are a lot of customers who save thousands of dollars by using the spot market. The dedicated instances. So the on-demand, reserved, and spot instances are on multi-tenanted hardware. For some regulatory or legal reasons, if your workload needs to be on single-tenanted dedicated hardware, then dedicated instances are your option to have a dedicated compute. So choosing the right mix of pricing model for your various workloads is quite crucial in achieving an optimum spend. And why am I again talking about this in autoscaling? We look at, when we come to the details of the autoscaling, we look at how we can use on-demand and reserved instances when you scale out. Let's spend a few minutes on what is a life cycle of an EC2 instance. So when you provision an EC2 instance, what are the different lifecycle stages that it goes through before it reaches its end of life? It's quite key to understand so that you can design your scaling strategies and parameters appropriately. Sorry. So you will typically launch an instance from an Amazon machine image or an AMI or AMI. So it's like a template. So we'll talk more about AMIs in some of the later slides. So as soon as you provision an instance, it goes into a pending state where resources are being provisioned and various initializations occur. Now, when the instance is ready for you to use, it goes into a ready state. So now you can log into the instance, or if you have got some automated services that are automatically started up on boot, then you can actually start serving requests using those services. Basic example, if your Windows instance is in ready state, you can remote login into it, RDP into it. If your Unix instance is in ready state, you can SSH into it. Now, there are two types of instances. There's an EBS-backed instance and an instance store instance. The basic difference in a nutshell is EBS-backed instance has a hard disk, so it can be stopped and started again, whereas an instance store instance is like an in-memory instance. It doesn't have a hard disk, so you can't stop it temporarily and start it. You can start it, you can terminate it. So if your instance is EBS based, you can stop the instance. So it will, from a running, it can go into a stopping state and a stopped state. When your instance is stopped, you don't pay for compute. You pay only for the EBS storage that is allocated to that instance. So if you've got a 50 gig EBS backed instance volume, you're paying only for the 50 gig of storage as long as it is stopped. If your instance is an instance store backed, obviously you cannot stop the instance, you can only terminate it. You can reboot either an EBS backed or an instance store backed instance. So when you reboot it, it will go through a rebooting stage and come back into a running state. And then when you terminate an instance, it goes into a terminated state. So you can see your instance going through these various states on the management console, or if you query using the CLI or the API. The key thing to note here is that an instance is up and running and serving requests only during the running state. So when it is in pending state, your customer, say for example, you're running a web server. So when it is in pending state, it's not serving web pages. Once it is in running stage and your services have started, like say for example, your Apache service has started and you have your HTML pages and CSS and whatnot in place, then it can start serving traffic. Why am I again talking about this? When you're auto-scaling, as we will see later, you are not serving customer traffic during any of the other states or during state transition. So you want to get your instance as quickly as possible to the running state, ready to serve requests. Moving along, we're going to spend a slide on what are the various instance types available to you. It's quite crucial to choose the right instance type. So unlike a physical machine where you just go by the number of CPUs and memory, here there are different instance types which do different things well. So it is quite crucial to understand what is the requirement of your application and choose an appropriate instance. So on this slide, you'll see various instance types and families that are available to you, and this is only a subset. This is only a subset of the various instances that are available to you. You can see detailed information about each of these instance types if you go to aws.amazon.com/ec2/instance types, or just Google for AWS instance types. It will tell you more about what is the underlying processor and what are the various characteristics of this. Just to gloss over some of these details, for example, general purpose is a generic. You don't know exactly what you need, go with your general purpose. If you're running some high HPC or really number crunching applications where you need a lot of compute, go with your compute optimized. If you are running graphic applications, go with your GPU. They've got GPU on board. If you're running in-memory database, you would probably go with the memory optimized instances. And then similarly, if your application requires a high storage and I/O optimization, then you would go with storage and I/O optimized instances. We're going to be talking some about Amazon machine images. It's quite crucial when it comes to auto-scaling, because when we talk about bootstrapping, which is the next topic, we'll talk about what we can do with AMIs. So what are AMIs? AMIs are nothing but a template. So all the instances that you provision are provisioned from a template. Now AMIs are typically based on operating system, the architecture, whether it's a 32-bit or a 64-bit, and the virtualization technology, whether it's a PV or HVM. So I won't go into the details of that, but that information is available on the public documentation. So these are the choices of AMIs that are available to you. So you can choose from Amazon maintained images, typically Amazon Linux, Red Hat, Ubuntu, SUSE, Enterprise, Windows. These are maintained by Amazon. You can go with them. Or you can go with community maintained images. So they are, let's say for example, CoreOS or CentOS or Debian. The community maintains AMIs. So you can, there are free AMIs and there are also marketplace AMIs where you buy these AMIs and pay for them per hour. So you can go with one of those community maintained images, or you can create your own machine image. Typically what people do is they probably take a Amazon maintained image, say for example Amazon Linux or Ubuntu or whatever. They put whatever patches they want into it, security, harden security, figure out access control, install any software they want, customize the operating system, and then you have the instance running and you have it how you need it. You right click it and make an image out of it. It's your own AMI. Now with these personal AMIs, the AMIs that you make, you have complete control over the access control to that AMI. So you can share, you can make your own AMI and share it with other accounts, or make it public, or make it a private AMI. So it's completely under your control. So a quick page which shows about shows the AMI. So these are Amazon maintained AMIs. You can see Amazon Linux, Red Hat, SUSE, Ubuntu, and then you have my AMIs, which will be your private AMIs or AMIs which you have created, marketplace AMIs, and community AMIs. So you can select it and then go ahead and start creating an instance. Then you'll have to specify your instance size and all the rest of the parameters. So we talked about the life cycle of an instance, and assuming you have used an AMI with just an operating system to launch your instance. So you basically have launched Amazon Linux instance. And when the instance is in running state, as we already mentioned, all you can do is log into your instance. So you still need to deploy any software that your application requires. You need to deploy your application before it can start serving customer requests. So those actions which you perform on a bare operating system to bring it to a state where it is a fully deployed application serving customer traffic, that process is what we call bootstrapping. So there are several options for bootstrapping. We'll spend some time on bootstrapping and show you a small demo as well. So every EC2 instance has metadata and user data available to it from the metadata service. So what is a metadata? So it can be an environment variable, it can be your AMI ID. So this metadata and user data that belong to an instance are accessible only from that instance. So a metadata is immutable information about the instance. And what can it be? It can be a host name, it can be the AMI ID, it can be the instance ID, network information, it can be the instance types. So you can query the metadata service from that instance by a simple HTTP GET. So when you do a HTTP GET of that 169.254.169.254 is where the metadata service is running. So if you do a HTTP GET of that URL, you get the metadata for your particular instance. So I can quickly show you the metadata for an instance that I have spun up. Give me a quick second. It's comfortably highlighted. So that is an AMI, an instance which I am running, and when I do a curl of that, which is a HTTP GET on that URL, I get a whole bunch of metadata. So this is the metadata available to this instance, which correspond to this particular instance. So I can go and say that give me the instance type of the instance, and it tells me it's a C1 medium. Similarly, I can query from this instance the metadata belonging to it. Going back to the presentation, and why am I talking about metadata and how we are going to be using it? We're going to be seeing it in some of the later slides. So that was the metadata, which is immutable information about the instance. You can also pass up to 16 KB of text to an instance on launch. So you can either do it on the management console or via CLI or whatever other method that you use to launch an instance. You can send a 16 KB of text, and that 16 KB of text can be a bash shell script or a PowerShell script or just a bunch of environment variables or whatever you want it to be. That user data will be available via HTTP GET to that instance as well. And what you do with it is up to you. We'll see a couple of ways to use that data. Typically what people do is they pass a bunch of environment variables, like say for example, server role is equal to web server. And when the instance launches, they do a HTTP GET of the user data, parse the server role, figure out that it's a web server and install Apache on it. Or if it's an app server, install Tomcat on it. Things like that. We'll see a couple of examples down the line. So that is how you would, on the management console, you would be able to pass the user data when you are launching an instance as a text. And in this case, they're just passing a bunch of environment variables. So now on your AMI or instance, you can run a script which runs on boot up of the server, it fetches the user data, parses it, and configures the EC2 instance on boot. So that is a rudimentary way of using it. So in Unix, Linux terms, you probably have an init script which is just doing a wget or a curl HTTP get on the user data and doing some processing with it. So that's one way of doing it. Another way of doing it is using the Cloudinit service. So Cloudinit is a service that is by default installed on Amazon Linux, Ubuntu, all Amazon managed Linux AMIs. On the Windows AMIs, it's called EC2 config. So that is a service that runs, and as soon as it starts the instance, on boot Cloudinit service starts, fetches the user data, and on Linux, if it begins with a hash bang, or on Windows, if it begins with a script tag, it will just execute it, right? So this is by default. This service is by default available on all Amazon maintained images. If you are managing your own AMI, or you're using something that Amazon doesn't provide, like say for example CentOS or something like that, this package is available via that particular distribution's package repo, or you can just compile it from source. So this is how possible user data could look like. So when you're launching an instance which is meant to be an Apache server and MySQL server and needs an elastic IP, that could be your user data to when you launch the instance. So all that is doing is it's installing HTTPD and MySQL server, and it is using an AWS CLI to associate an elastic IP with that particular instance. Now notice that when you associate an elastic IP, that is your elastic IP, and then you need to give it an instance ID. So when you're launching an instance, you're not going to know the instance ID. But once the instance is launched, the instance ID is available via the metadata information. So here they're using the metadata, calling on the metadata service to get the instance ID and associating it with the elastic IP. So till now we have spoken about a couple of techniques to get an instance from launch to a state where it is ready to service requests. So we talked about an AMI where you can manually install whatever software you require, deploy an application, bake it as an AMI. When you launch an instance from that AMI, it is ready. Once it's in ready state, it's ready to serve requests. Or you can launch an instance from a bare OS and use this user data or metadata to configure it dynamically. And when you can also use other configuration management tools like Puppet, Chef, this AWS OpsWorks, Ansible, Salt, a whole bunch of things out there which can do configuration management for you. So these are the two ways in which you can get a server from launch to a running state where it is ready to serve customer requests. Now, both of them have advantages and disadvantages. So which is the method, ideal method to choose? So AMI, you build your base images, set up custom initialization scripts, and you're managing a golden image. Whereas when you configure dynamically, you're using Bootstrapping to pass custom information in, and you're configuring the instance post-launch and bringing it to a desired state. Now, the advantages of AMI baking are that this is the shortest time from instance launch to servicing requests, because your AMI already has everything that you need, and as soon as you launch it and it's in running state, it is ready. It's ready to go. There is no in-place configuration, so every time you need a new server or you want to kill an old server, there's no in-place configuration. You're killing a server and spinning up a new one. You simply throw away your old instance and you create a new instance out of your new AMI. The disadvantage of AMI baking is that if you're baking an AMI, any small change in code will mean that you need to bake a completely new AMI. Also, version control of AMI can be a bit cumbersome. What is the advantages of configuring something dynamically? You have a very generic AMI and the application configuration happens dynamically after boot. So any change in code only involves a minor config step. And it is also easy to version control your configuration scripts, be it user data scripts or Puppet, Chef scripts. You can just version control them along with your source code. The disadvantage depending on how much post configuration you are doing, your instance is going to, from your instance start reaching the running state, for it to start serving your customer request is going to take some time. For example, you have a massive web application to deploy into Tomcat, so that might take a few minutes. To install Tomcat will take a few minutes, configure it, secure, harden your operating system. Each of that step is going to take some time. So from the minute you launch your instance to the time where you can serve customer requests is going to be more than an AMI baked method. So the ideal technique is to kind of find a sweet spot between these two, which works for you, and that would completely depend on your application. So just to give you an example of how to find the sweet spot, let us consider an application, and let's assume that that's your stack. So you've got your Linux operating system on which you have a JVM, and you have your application uses some framework like Hibernate, Spring, Log4j, and Struts. You need an Apache server, you need a Tomcat server, and then you have your code here. Apache Tomcat, I'm guessing that you'll have a bunch of static files, and then you'll have an EAR file which can be deployed into your Tomcat. So if that is your application stack, how does an AMI baking look, and how does configuring dynamically look, and how do you find the sweet spot? So AMI baking, it's simple. You spin up a basic Linux instance, you install JVM, you install all your frameworks, you install Apache Tomcat, configure it, deploy your application, everything is running, ready to serve customer requests, bake it as an image, and then however many images you want, you just use it like a quick cookie cutter, use that AMI to spin up as many instances as you want. So that's how you do an AMI bake. If you were to configure it dynamically, what I'd probably do is I'd have a Linux operating system, I'll have JVM, and probably a chef or Puppet agent or CFNinit or whatever configuration management method you're using. That would be baked as an AMI. And then you would launch from this AMI and then use one of your configuration management tools or UserData to install Apache, Tomcat, configure them, deploy libraries for all your frameworks, deploy your application. So now that's going to take time. So once you launch your AMI to your code finished getting deployed and starting to serve customer traffic, that's going to take time. So what is a possible sweet spot? Maybe an AMI could be your Linux operating system, your JVM. It could have Tomcat and Apache installed and configured. Maybe it could even have the libraries. And then you launch an instance from this AMI, and when the AMI launches, you use your configuration management tool just to pull your application code and deploy it. So the time that it's going to take is the time it's going to take to deploy your application, and that way when your application changes, all you need to do is spin up. You don't need to spin up a new AMI. You use the same AMI. Your application is maybe stored in an S3 bucket. The new AMI pulls it from the latest location, and that's all you need to do. So that is an example of how to achieve the sweet spot. A few tips. Why do we want to do this? Automation, less fingers make less mistakes. Availability, you drive higher availability with self-healing. So when you have this, you've got your sweet spot, you've got everything automated, an instance goes down, you spin up something else, another instance from the same army, it will self-configure itself and self-heal. Efficiency, audit and manage your estate with less time and effort, everything is automated. Scale, you manage large-scale deployments and you drive auto-scaling. So any manual step, you're not going to be able to scale. You need automation. If you want to scale up to 1,000 instances, you need to be completely automated. The whole thing is completely flexible. You have a lot of choices, like we talked about metadata and UserData. You have your PowerShell, CloudFormation, Chef, Puppet, OpsWorks, a whole bunch of options. Key thing is also instances locked down by default. So when you're spinning up an AMI, you harden it once, and every instance that you spin from that AMI is going to be hardened. And you're not doing any in-place configuration. So if there is a security vulnerability, say your instance has been hacked and there's somebody has left a backdoor in there, the next time you do your next deployment, that instance is going to be thrown away and a completely new instance is going to be there. So which is hardened and secure by default. So there's a big security paradigm in that as well. Some do's and don'ts. Please use IAM roles and do not use keys if you can. So do not even generate access keys and secret keys, just use IAM roles. Strike a balance between AMI and dynamic bootstrapping, that is, spend some time and try and find your sweet spot. Don'ts, do not put your API access keys into code and publish into Git or bake into AMIs and share them. So once anybody has access to your keys, they have access to spin up whatever they want on your account, and you'll spin up a huge credit card bill. So please do not put your API access keys into code. Always use IAM roles. Just a couple of slides on EC2 with CloudWatch, maybe even one slide. So that is how your CloudWatch looks like. CloudWatch is an AWS service that enables you to monitor all other AWS services. It's quite important that any other metrics and monitoring system that you might be using, say for example Zabbix or Nagios, it's important that they tap into CloudWatch metrics, because CloudWatch gets metrics from the underlying hypervisor as well that your external systems are not going to get. So it's quite key to look at CloudWatch. In CloudWatch, you can create thresholds for metrics, you can raise alarms, and you can configure to take appropriate actions like sending a message to a notification queue or sending an email if you get an alarm. So that is CloudWatch. So now we're going to try and put all these things together. Instance lifecycle, instance types, your armies, your user data, your CloudWatch, everything together to see how they all fit well and can you can leverage scale of AWS. So there are two types of scaling. You can vertically scale, and vertical scale is where you change the instance size. So you go from a smaller instance size to a bigger instance size. Firstly, why do we want to scale? You're running an application on a particular instance and you're hitting some of the limits of that instance. So you're either hitting CPU limits or memory or disk IO, and you want to overcome those limitations. So if you scale vertically, you spin up a bigger instance, you increase your EBS capacity, so you get more disk. You use provisioned IOPS, so you get more IOPS. So for example, if you say you're using an M3 medium and you're hitting some limits, you can go to a C3 2x large, which is bigger, it's got more CPU and more memory. Or you can go to an R3 8x large, which is our largest instance. You get 32 CPUs and 254 gig of RAM. So you can scale vertically. So you can either scale vertically or you can scale horizontally, which means that you already are running an instance, you just add more of the same instances behind an elastic load balancer. And if you can auto scale, we'll come to auto scale a little later. So which means that you're overcoming your limitations by throwing more of the same instances at it. That would be horizontal scaling. Now, with vertical scaling, we saw so many different instance types. You have high memory, so depending on what is the limitation that you're hitting. If you're hitting CPU limits, you probably want to go for a higher CPU instance in the high CPU family. Or if you're hitting memory limits, then maybe you want to go for an instance with higher memory. It's quite easy to change the instance sizes, but the instance needs to be stopped. So which means that you might have a downtime depending on your architecture. If you have a highly available system across two availability zones, you might be able to bring down an instance in one availability zone, spin it up to a larger instance, and then do the other availability zone without much of a customer impact. Also, you will hit an endpoint eventually. So the R3 8x large is one of the largest memory instances. So if you hit that limit, there's nowhere else you can go. So you will need to, at that time, consider horizontal scaling. Also, scaling vertically doesn't really solve the traditional IT usage problem, which is the problem of over provisioning, right? How do you capacity plan? You still need to capacity plan if you're vertical scaling. So what is the traditional IT usage pattern? There are a few patterns we see. Typically the on and off, these are typically the batch processes, batch jobs, which switch on, do something for some time, and then switch off. You have the fast growth where you find the capacity requirement is slowly increasing. You have variable peaks where you really can't predict, it's going all over the place. And then you have the predictable peaks. You know that you're going to do this high CPU calculation every 6 hours. So that is a predictable peak. Now the gray line shows the provision capacity. That is how much compute power or memory or I/O you have thrown at it. Now all those orange bits are a waste of capacity. So you're not using them, but you're paying for them if you've already provisioned it and considering immutable static resource. You're wasting all that orange bits, and that is money you can save, right? And all the green bits is where you're having a poor customer experience. You have provisioned to kind of meet your average load, but when it spikes, customers are getting impacted, and that is basically poor service. Now, this is the traditional IT usage patterns, and if you're doing kind of applying the same principles as you on AWS, you're not solving the problem. So what is cloud IT usage patterns, which autoscaling is a key component of, which helps you with? You're getting just-in-time resources. So that red line is AWS compute resource or whatever, your instances, right? That's your capacity. Now, with horizontal scaling, that is the usage pattern that you can achieve. The red line shows the capacity available to the services just in time when you need it, and you pay for what you use when you need it. Now, you have to know your application really well, and the fine-tuned your configurations are for autoscaling, the tighter is the capacity versus the demand graph. And the tighter that gap is, the better is your customer experience and cost savings. Right? So this is how we relate cost savings to autoscaling as well. Right, we're going to spend some time on this slide. So we mentioned autoscaling, and we already covered vertical scaling, and we saw that you're going to hit the limit at some point in time. The rest of the talk is going to be about horizontal scaling. So how is it done? How do you horizontally scale on AWS? First of all, the last point, it's free. You don't pay anything for the autoscaling service. You only pay for the instances that you spin up. It is the automatic resizing of compute clusters based on demand. So you can define a minimum and a maximum number of compute instances, and you can define the criteria when you want to scale out and when you want to scale in, and all that is based on metrics. So when you scale out, that is, you find that the load is increasing and you need more capacity, your autoscaling service will automatically spin up a new instance and add it under the load balancer and start sending traffic to it to meet your increasing demand. And when autoscaling instance spins up a new instance, all those bootstrapping techniques we talked about, they are going to come into play. So when autoscaling service automatically spins up an instance, you want that instance to be in service as soon as possible. Now all your bootstrapping techniques, you're finding a sweet spot, that's where it matters. So when you launch a new instance and the time it takes to come into service, that has to meet the rate of increase of your demand. So I want to talk a little bit about the metrics as well. So I said scaling depends on metrics. So we talked about CloudWatch and how you can use, say for example, you can use one of the CloudWatch metrics, CPU utilization, to scale. So for example, you can say if CPU utilization of my compute instance is above 75% for 10 minutes, spin up another instance to balance that load. So that's what I'm showing in the diagram, wherein we're saying that the usage metrics are going to CloudWatch. CloudWatch is giving us a feedback. There's an alarm raised because it's gone above 75% for 10 minutes, and the CloudWatch initiates a scaling instruction, which is going to add auto scaling to the group. It's going to spin up a few more instances to balance the load, and your CPU, the CPU utilization of the group is going to come down. On cloud, so CPU utilization is one metric that you can use. CloudWatch gives you a lot of other metrics that you can use to auto scale. You can also create custom metrics very particular to your application, so you can base your scaling decisions on your custom metrics as well. There's another metric that you can use, which is I talk about queue metrics. So this is another design pattern that I want to talk about. A lot of customers design their application in a loosely coupled manner, right? So for example, if you have to communicate between different layers or subcomponents of your application. You do that by passing messages through queues. So you don't directly make RPC calls or SSH remote procedure, remote calls or whatever it is. You kind of loosely couple it by actually passing your messages through queues. So, for example, if you have say a photo gallery application, something like Flickr or something like that, users can upload pictures, and you want to generate thumbnails and images of different sizes so you can display them. So your application user might put the images, and they might be uploaded to the S3 bucket, and your application might pass a message to a queue saying that user has uploaded this image. So Amazon has a SQS service, which is a queue service. Push a message into the queue. Now there might be a fleet of instances, so a fleet of auto-scaled worker instances, which can take this, which are always reading messages of this queue, and they take the message of this queue, fetch the image from S3 and resize it, and store it back in another location. So now it's your metric, if it is CPU, is not very appropriate. So maybe your metric should be the depth of the queue. So the more items or more jobs there are in the queue, the more number of instances that you want in your auto-scaling group. So your metric could be your queue depth, and you could auto-scale and scale out and scale in based on that metric. So just CPU or memory or disk I/O is not a valid metric. You can create your own custom metrics. You can use queue metrics. So I also talked about developers developing applications. And when you're developing applications, you don't want to be developing monolithic applications. And I already talked about loosely coupled applications. I want to spend a minute talking about that as well. So in order for your application, if you're designing an application from scratch and you want to design it in such a way that it can horizontally scale, what you need to do is you need to make your application stateless. So as long as you are storing state in, or say for example a session or whatever it is, in your instance, you can't horizontally scale. So typically you want, when you want to make a application stateless, you remove the state out, or sessions or whatever it is, out to a caching layer or a database or a NoSQL database or something like that. So what you want to do is you want to be able to start an instance and deploy your application with a configuration, and away it goes, start serving traffic. Now if that instance terminates for some reason, there should be no customer impact, because the state is stored somewhere else and another instance spins up, picks up that state and continues from where it left off. So all the state information and data need to be abstracted out into a cache or a database. The various subsystems of your application communicate with each other through event notification and message queues, like I talked about in the last example. You want to design your application in such a way that you can spin up any number of instances with the appropriate configuration. You point them to the right cache and the database and the message queue. These various components will register themselves or do a discovery of the other subcomponents, and they will just start to function like a well-oiled machine. So this application can serve dozens of users. So if you're starting off small and you just have a dozen users, if you have architected it right, you spin up this application, it serves dozens of users. Suddenly you become very popular, say like Angry Birds game or something like that, and you have tens of thousands of users flocking to your site. You don't need to do anything. The entire application just scales up horizontally automatically with absolutely no effort from your part. All right. So basically, these are the various components of auto-scaling group. So you have a launch configuration. So that defines what auto-scaling will create when it adds new instances. So you have your AMI, your instance type, your security group, and your key pair in your launch configuration. You have an auto-scaling group, which is the managed group of EC2 instances. So you say, I want a minimum of so many instances, a maximum of so many instances, and at all points in time, I want to maintain this desired capacity. And this auto-scaling group has an automatic integration with Elastic Load Balancer, which means that when instances are spun up, they get automatically added to the load balancer, and the load balancer starts serving traffic to them if they are healthy. You have auto-scaling policies. So these are the policies: scale up and scale down actions, and cool down period where you don't want any scaling action to happen. There are also different scaling plans you can do. So you can scale based on demand. So if your CPU utilization goes above certain range, you scale. You can do manual scaling. So if you know that you're going to get some load now and you want to automatically, you want to manually scale it, you can go and change the desired capacity and it will scale it. You can scale based on schedule, which means you know that you're going to get a batch job between 3 a.m. and 5 a.m. in the morning. You just scale based on schedule. You also maintain, scaling also used to maintain current instance level at all time, which means, for example, you have, all you need is 2 instances behind a load balancer. That's all you need. You still worthwhile putting them in an auto-scaling group with a min of 2, max of 2, desired capacity of 2. That way, if any of the one of the instances goes down or gets to 100% CPU or something like that, auto-scaling service will automatically spin up another one and manage this at 2 instances at all time. I want to quickly go through some of the auto-scaling life cycles and maybe get into a demo as well. I've kind of overshot my time by about 5 or 6 minutes. That's all right. So what are the auto-scaling life cycles? So you have an auto-scaling group, and based on a metric, CloudWatch metric or a schedule-based event, you have a scale-out event that is happening, which means auto-scaling service will launch a new instance, a bunch of bootstrapping will happen, and it will join the auto-scaling group. So now that is joined an auto-scaling group under an elastic load balancer, and it is serving traffic. Now, because of another metric, there is a scale-in event which is called, which means auto-scaling service will remove one of the instances from the auto-scaling group and terminate it. So how does it choose which instance to terminate? So it applies a termination policy. So auto-scaling service would actually automatically balance your instances between 2 availability zones. So if it is imbalanced in some way, it will automatically rebalance it. So it will first check if there is any of the availability zones has more instances than the other one. If it does, it will terminate an instance in the availability zone with more instances. Then it will look at which one has an oldest launch configuration. It will terminate the one with the oldest launch configuration. If all things are equal, it will determine which of the instance is closest to the next billing hour. It will terminate that instance, hence saving you money. So that is how the management control of an auto-scaling group looks like. So you can create a launch configuration or an auto-scaling group. You can choose which AMI for your launch configuration. Those are some parameters you give for your launch configuration. IAM role, you definitely want monitoring enabled. You can give your user data for your launch configuration. That is your auto-scaling group. Start with minimum instances, ensure that's the desired capacity and that's the maximum capacity. Where do you want to place these instances in a VPC, subnet, add it to this particular load balancer. And your scaling policy, so if there is a CloudWatch alarm, what do you want to do? Add scale out instance would be add by 1 instance, or you might want to spin up 2 more instances. So a diagrammatic representation of how this auto-scaling would happen is you have 2 availability zones. There are 2 instances in each availability zone under this load balancer. If one instance goes down, auto-scaling will spin up another instance automatically. If an entire availability zone goes down, it will spin up 4 instances in the other availability zone. There's absolutely no customer impact. Now, if for some reason the availability zone which went down came back up, auto-scaling service would automatically rebalance these 4 instances. It will become 2-2 again. So independently, they work really well. Elastic Load Balancer does what it does really well. CloudWatch metrics, auto-scaling, combine all these through. They work really, really well, and you get a lot of flexibility. We're going to get into a quick demo. So what I have for a demo is multi-AZ load balanced auto-scale web application. It's just an Apache web server which is showing a website, and it is running on an M1 small instance. I've got an application, not an application, it's a tool called Bees with Machine Guns. It's a performance testing tool. So I'll show you how to use the performance testing tool. What it does is it just spins up a bunch of bees and hits this website which you give it as many times as you say you want it. So it's a performance testing tool. Other people would call it a DDoS tool as well, so you want to be very careful with that. What is the expected result? We are expecting that this Apache server will scale out. So you will see it scale out multiple instances to serve traffic. So what are the parameters that I'm using? I'm going to be using a minimum of 1. So there's going to be 1 Apache web server to start with. It will scale up to a maximum of 3. I've got a cooldown period of 300 seconds. I'm scaling out. I'm keeping this metrics quite low because I want to show you that it's happening in a short period of time. So if my CPU utilization goes about 20% for 60 seconds, it will add one more instance. Scale down policy is if it is less than 10% for 2 consecutive instances, it will scale down. It will remove an instance. Piece with machine guns, as I say, it's nasty. Be very careful when you use it. All right, so I'm hoping that you guys can see the page. So what I have here is, okay. So I've got one Apache web server. That is the website it is serving. And all that is just a JPEG, showing it as JPEG. So you can see that these 2 Apache servers have been terminated. So there was, when I was testing it before, the scale out event happened and then it scaled in, which means it has terminated both of them. There's only one running instance at the moment. So we're going to look at its CPU usage. CPU runs every 1 minute. So you can see that the instance started off somewhere here and then the CPU has been like 1 or 2, 3%, whatever. So now I'm going to go and start my bees and start attacking it. Conveniently saved that. So when I'm saying start swarm, what I'm saying is I've got 2 bees, 2 instances. So each of these bees is going to fire 150,000 rounds at this M1 small web server, 500 at a time. So at any point in time, the web server is going to get hit with 1,000 requests up to 150,000 rounds, right? So the B0 is firing his machine gun, B1 is firing his machine gun, bang, bang. So it will take some time in the sense like the monitoring is every minute. So we'll come back and look at what happened, and we'll see the web server scaling as well. All right, while it's happening, I'll continue with a couple of more slides and come back to this. So auto-scaling isn't one size fits all. You need to choose the right metrics. You need to choose CPU usage, queue depth, number of concurrent users. You can't scale too aggressively. If you scale too aggressively like I'm doing now, you're over-provisioning, which means you're increasing cost, and you're also bouncing because you need to scale back every now and then. And if you scale too timidly, you're going to have customer impact. You're going to have poor performance. You're going to have outages. So the technique is to scale out early and scale in slowly, and find that sweet spot that works for your application. Few things to stop doing. Do not provision and fix your servers. Do not name your servers. Do not treat them as pets. Treat them as mutable resources. Don't treat them as physical things. You spin them up when you want them. Spin them down when you don't want them. Start doing this. Build systems secure by default. Stateless auto-scaling applications. Create instances when you need them and drop them when you don't. Play with instance types. Tag resources. Goodbye to capacity planning. You don't really need to do that anymore. Replace, not fix. So don't do in-place configuration. Just replace the server, throw it away, create a fresh one. Before we get into these advanced tips, let's see if the bees have done their job. Yep, you can actually see that traffic spiked to about 30–40%. Bees are finished. Let's see. I'm going to get the bees going again, just in case. Let's see if it is auto-scaled. As you can see, there are 2 Apache web servers running now. There's one Apache web server running, and there's another Apache web server running, and that was because CPU utilization spiked to more than 20%, which was my threshold. And since I'm running bees again, it is going to continue. You can see the second one is just initializing, so it's just coming into service, and we can go down to the auto-scaling groups and see that it's got 2 instances now. So you can see note that my bees machine gun is also an auto-scaling group. So instances in this auto-scaling group, there are 2 services which are in service now, and you can see the scaling history. It will show you at what times it scaled up and scaled down. So it had launched few were successful scale. That was a terminating instance. It has just launched this new instance. You can also, I've actually subscribed to SNS notification, so it will email me as well, which you can't see at the moment. So that was the demo. That was the last slide. So just some new things, advanced things that you can do at the moment. Now you can have an auto-scaling group and you can manually attach and detach instances from your auto-scaling groups. You can also put instances into a standby state if you want to do some troubleshooting. If you're putting an instance in a standby state, it will not count towards your desired capacity in your auto-scaling group. So you can instance life. So which means initializing it in service, it will in fact, you can use the hook to actually do some terminate like a hook and actually move logs of that instance before it terminates or something like that. So you have this instance lifecycle hook. You can also create an auto group or launch configuration based on current running instance. That's is new, already meant auto scale. So these are some usage patterns for auto. You've been asking a lot. Architect to it, most commonly asked questions, and there's a separate ask this. Let process and the specification use of those and